when V out is 0. But what do I mean V out is 0? I mean V out in AC is 0, meaning in DC it's not going to be 0. And this means that V in AC is not 0. But in DC it's also not 0. So this is, again, if we go back to the design, we see that there's a DC operation point for the amplifier. Both IP and IN will be connected to it. And on top of that, we are going to have an AC signal to measure the GM. Usually you want to put 1 volt for the magnitude of the AC signal, because it doesn't really matter once you're in that operating point. It doesn't really matter how much you move around it. The simulator does basically the same thing. So it's just easier for the calculations. On the other hand, I will want to measure the R out of the circuit, and we know that R out is going to be 1 over I out over V out, where here V in is going to be 0. And again, here V in is 0 in AC, but in DC it's not. So if we go back to the design, and for the R out simulation, I will want this still not to be 0, because I need the amplifier to stay in the operation point. Whereas here, I cannot pull V out of the operation point. So what I do is I connect something that we call a DC block. This is from this library, analog lib. It's called the DC block. Basically, what it does, it blocks any DC from going through, and it passes AC. So it's a big, very, very big capacitor. You can basically just put a 1 farad, capacitor. It's basically the same thing. So what we're going to achieve by doing this is, once on the left side we have a DC, this output was going to stabilize in its operation point on the graph that we've shown of I out over V out. And then we're going to apply the difference around that point when the inputs are constant, and that's how we're going to measure R out. So this is our circuit. On the top right side over here, we just have the same circuit where we're going to just measure the open loop gain of this circuit. We know that in the end, the gain of every circuit is always at least in absolute values, just GM times R out, and this could just be very helpful in any circuit you have. So so how do I do this? It's very simple. For once you got this, you basically got the whole thing. I have created a test to measure these parameters. The GM test that you've seen inside the AC sources, we had one here, which is GM test, and one here, which is one minus GM test. So when I'm going to run my GM test, the right side is not going to apply any voltage, any AC voltage, and my GM test is 0. So the left side is not going to apply any AC voltage. This way, it's just very easy to control the test bench. And I have measured in the setup, I've just measured that all my transistors are in the correct operating point, meaning I would like them to be all in saturation. So I know that my R and GM parameters are the most real, and they're in the range that I want. And then I'm just measuring the DC points just to make sure that I'm okay, and I'm taking also the open loop operation right here, dB20, and VF of op is the open loop amplifier. And here's the interesting part. So what are we going to be doing here? So we want to measure I out when either V in is 0 or V out is 0. So we're just going to be measuring this expression right here, IF, which means I in the frequency domain, for I0 op, and that's just the current going into the amplifier. And then on that,